This is Make a Palindrome, Problem 5 from FBISD UIL Practice 4. The problem is, given a string, find the fewest number of characters you need to add to the beginning or the end of the string to make it a palindrome. The string will consist of only lowercase letters, and the string's length is at most 1 million. So let's look at an example. So here we have a string of length 5, AAABB. So immediately we can see that if we were to construct a palindrome, two immediate constructions come up to mind. So the first one is just adding two B's to the beginning. So that'll be B, B, A, B, B. And the second one would be adding three A's to the end of the string. So A, B, B, A. So initially off of this, we can make some observations. So the first observation is that we don't need to add characters on both ends of the string, because if we eventually have a string that we've added to on both sides to construct and is a palindrome, then we can always, so if this is a string and let's just say there's some characters like A, dot, 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 and the end is also A. And then the actual string that was given an input is here. So since we added characters on both sides, like in this example, then and it's a palindrome, then we can always remove one character from the end and one character from the beginning. So from this we can conclude that we only want to add characters on one side of the string. So the next question is, which side of the string do we want to add characters on? So if we look at these two examples, it's clear that we want to build off of a palindrome that's already in the string. So basically we want to choose the side that has the longest palindrome already built into the input string. So in this case, we have on the left side a palindrome of length 3. Well, on the other side, we only have a palindrome of length 2. So it's clear that we want to build off of this side. So there's a solution. So all we have to do is basically look through the string and see what's the largest palindrome you can get from starting from the left side, and what's the largest palindrome you can get starting from the right side. So let's move on to coding. Okay, so first I'm just going to import so for this problem we're going to have to use the subprompt to that solution would be that we need to have a way to find the or to check if a string is a palindrome. So to do that in O of 1 time, we can use a technique called hashing. So if you're not familiar with that technique, you can look it up. Just search up hashing. So first I'm going to import my modulo library. If you want to see, if you want the code to this library, I'll link my code library in the description. So then we can start, we're going to set the limits. So this is the maximum length of the string. And then we're also going to define the base for our hashing. So we're just gonna input read in our string, and then we want to generate. So for this, when we generate our hashing, we want to make like a prefix array of our hashes, so then we can easily use prefix sums to look at a specific substring's hash. So I'm going to go ahead and declare the two arrays. So here we have pre and suff. So prefix is all the prefix sums and suffix is all the suffix sums of all the hashes. So to check if a given substring is a palindrome, we can check if the prefix sum for that substring matches the suffix sum for that substring. That's basically comparing the substring with the reverse of itself. which is enough to satisfy, to check if something satisfies the palindrome. So we're gonna just set up our prefix and suffix sums. Size here is a macro that just tells you the size of the string. So notice here I'm using methods called add and mul. So these are part of my modulo library that makes it easier when I do addition and subtraction. It basically mods for me, just to simplify the code. Fast expo is a method to do powers, but it computes something to the power of I in log I time rather than in linear time. So now we're gonna set up the suffix sums. Alright, so now we're gonna start reading. Now we're gonna start checking for the longest palindrome you can find at the start of the string. So we're checking if the prefix sum for the substring is equal to the suffix of the substring. And all of these computations I'm doing right here are computations for or hashing techniques. So if you don't, if you're not familiar with them, be sure to check it out. So here I'm just saying that if this substring does equal its reverse, then we're gonna set the largest start palindrome at the start of the string to I plus 1, which is its length. And we're just gonna do the exact same thing for the end of the string. Oh, oops. Alright, so we're done with. So now that we've checked for the largest palindrome at the start of a string and at the end of a string, we can output the answer. So the answer, so if we go back to our drawing pad, the answer, so if the largest palindrome that was a substring that started at the beginning or the end, in this case it's 3, the answer would just be, oh, whoops, I don't know what happened there, 3. The answer would just be, well, like when we construct a solution, we just need to replicate the part of the string that's not a part of the largest substring palindrome. So in this case, it would just be the size of the string minus the largest palindrome. And this is our answer. Whoops, not used to this drawing pad. Yep, so that's the answer. And we're just gonna output it now. So there we go. That's the solution. Let's see if it gets all the test cases. Okay, it does. That's the solution to make a palindrome, problem 5.